Hello the internet and welcome back to Tony259, Tony359's second channel. Today on the bench I have again the FNIRSI DSO-TC3, which I've introduced on my main channel on this video. And on this video here on the second channel I thought I would do a little bit of a follow-up, and I'm gonna explain some of my findings on why this is behaving the way that I've noticed in the main channel, and I'm gonna explain how these component testers actually work and maybe answer some of your suggestions and questions that you kindly left under the main video on the main channel. Now, I don't have a proper LCR meter to make a comparison, not yet, but another YouTuber, one of my viewers, made a little comparison basically for me. So towards the end of the video, I'll show his finding, and I think they're going to be pretty enlightening on what's happening with this FNIRSI thing. Now, the main reason I got these TC3, as I said on the main channel, is for the component tester. This one is still working, but the ZIF socket here is pretty worn out. Sometimes it doesn't take the components because again, it's pretty old, it's missing a case. And I thought, well, these hopefully can replace my old component tester here. And the main reason I'm using the component tester is for testing like transistors, MOSFETs. They're not easy to test with a multimeter, but mainly for capacitors. Not just for the capacitance, but for the ESR reading, equivalent series resistance. And the reason is that you might have a capacitor which is reading totally fine from the capacitance perspective, but the ESR is completely off the scale, and that makes the capacitor as bad as if it had a completely wrong capacitance. So the ESR reading is an important parameter, and I was hoping to get I don't want to say an accurate device to read that. I don't need that kind of level of accuracy, but at least something that can tell me pretty reliably this is good, this is bad. So we're going to do some tests with these things. I'm going to share you a few interesting things I found. We're going to use the oscilloscope as well. And the first thing I'd like to answer is calibration. Many of you said, well, you need to calibrate this, you need to calibrate this. And I can assure you that I did calibrate the FNIRSI before I shot the video. And the calibration is pretty simple. All you need to do is to get some pins. And I soldered together these resistors legs, so there's no resistors or anything. And all you have to do here is to go to the main menu. There's a calibrate feature. It says, please short probes. And all I'm doing here, I'm shorting the probes. The calibration is starting. It doesn't ask for a capacitor. I know that some of you mentioned that, and it is in the original design of these component tester. It doesn't need that for whatever reason, and it just completes. And I definitely did that before shooting the video. There you go, test end. So I don't know, I guess it's done, and again, it's now calibrated. Now, when it comes to this older tester, I was told that he also had a similar calibration menu, and I didn't know about that. I was like, oh, wait a minute, I've had it for so many years, I never calibrated it. So I placed the same pins in the slots 1, 2, and 3, but if I start it, it doesn't start the self-test. It should say self-test. I found something online. But no, it's only measuring the pins, basically. It's measuring the resistance. So I don't know exactly why it's not doing it. I'm assuming the firmware that was installed on this thing, again, it's like an Arduino. So the firmware that was loaded into the chip, it doesn't have this calibration thing. Or maybe it has a different procedure, but I don't know. Again, I can't remember where I got it. I think it was from eBay, so it's no point in finding a manual or anything. Anyways, so I can't calibrate that one. Now, many of you have mentioned the reason why the ESR was reading completely different on the FNIRSI compared to this one is because of the testing frequency. And indeed, I found that when it comes to ESR, you can test it at 100 Hz, 1000 Hz, 10,000 Hz, and 100,000 Hz. So depending on the frequency that you're using, the ESR can change quite dramatically. I found evidence that it can change between like twice as much or up to like 10 times as much. So that's why I think I was asking somewhere, I cannot remember where, unfortunately, but someone told me ESR without the used frequency for reading it, it's pointless. Because if you're reading on the same component, the ESR at 100 Hz, and then you're reading from the same component, ESR at 100 kHz, the result is going to be completely different with the same component and with the same tool. So you need to associate that with the frequency. And if you're looking at capacitors data sheets, the manufacturer actually adds a note where it says, well, the ESR indicated in this table is read at, I don't know, 120 Hz or 100 kHz. So many of you said plug your oscilloscope into these testers when a capacitor is being read, and hopefully you can see what frequency is being used, and that will probably explain why the reading is completely different. So that's what I did. I plugged this Panasonic 1200 microfarad 35 or 25 volts FR series, so that's very low ESR, into the component tester, and I got my oscilloscope connected to it. And the oscilloscope is in roll mode, so I think it gives you a better idea of what's going on. And if I press the OK button and I test it, you see that this is happening. You have some stuff. Now, I can assure you that I looked into that waveform and then eventually stops and it remains negative for whatever reason. I looked into that waveform, like stopping and magnifying and everything, and I couldn't see any high frequency switching of any sort. And it's reading 1300 microfarad, ESR of 0.14. So, it looks like it's a good capacitor, low ESR, and the capacitance is correct. Now, if I'm checking the other component tester, let me discharge this capacitor just in case there's some residue, because these components tested don't like when there's some residual charge. So I'm in the other component tester, and if I'm testing it, you see something similar. You see these strange waveforms, but there's no high frequency. There's voltages going up and down, and eventually you have your output. The capacitance is a bit different. It's 1.2 compared to 1.3. The ESR it's close, but if you think about it, it's twice as much, and the V-loss is more or less the same. So, I spent quite some time looking at those graphs, and I was trying to find some high frequency, and eventually I ended up on the original documentation of the component tester, and I found why these are not using a high frequency signal. Well, I don't know this one, maybe we can have a look later on, but at least the original product here, it's based on a AT Mega 328, if I'm saying that right, if I remember right. It's basically an Arduino that cannot do 100 kilohertz. There's no way you can do that. So the engineer who designed this, well, the original tool, not these tools, but the original tool, came up with some electronic trickery to come up with an ESR reading which is approximating an actual proper reading using high frequency. Now, the documentation is explaining everything. I'm not a massive expert, so unfortunately I'm not able to explain it back to you. But the idea is that he did lots and lots of testing, and apparently his method was very consistent with reading ESR with a proper ESR meter set to 10,000 kilohertz. The document said, and it's a pretty old document, so maybe things have improved over time, but the document said, I cannot find an alternative way to measure ESR comparable to 100 kilohertz, but definitely I find this method which seems to be consistent with the 10 kilohertz reading. So unfortunately, that's a bit like kind of the end of the line, because, okay, this is not using a frequency, so the ESR is coming out of it is kind of like inaccurate, random, and again, I'm totally aware of that. All I'm looking from these tools is tell me if the component is good or bad. I'm not looking whether the ESR is 0.14 or 0.17. No, I just need to know, is this component good, is this component bad? And if I need a proper ESR reading because I'm designing something which needs to have a very precise low or high ESR or whatever, then these are not the tools, okay? I'm using these tools just to ascertain whether a capacitor is in good shape or bad shape. So 0.14, good, 7.8, bad. That's it. But unfortunately, in the main video I made on the main channel, there was this kind of difference between this one and that one. So that was making things a bit like big question mark, which one do I trust? This is the capacitor I used on the main channel video. It's a 10 microfarad SMD capacitor, and it reads an ESR of 1.5 ohm on the FNIRSI, which is okay for such a small cap. but a massive 16 ohms on my older tester, which suggests that the capacitor is junk. Now, many of you came up with a good idea. If I solder a resistor, a known resistor, to these capacitors, I should see the meter measuring this resistor as the ESR. So if I'm adding, I don't know, a 10 ohm resistor, now ESR is supposed to be what was read before, which is 0 point something, plus 10 ohms. So it's going to be 10 point some ohms. And that's exactly what we're going to do. Let me find the resistor, I'll solder to this capacitor, and we'll see how these two meters react to that. Alright, so I've got the same capacitor we were reading before with a 33 ohm resistor in series. So let's see what this component tester is reading now. And I've got more or less the same capacitance, it's 1.281 microfarad, and the ESR is 34, which makes sense. It was 0.2 before, the resistor is 33, again, nothing super accurate, but 34 is more or less there. I'm reading 33 plus the ESR of the capacitor, so that works totally fine. Now, let's check the same contraption here into the FNIRSI and see what it says. Well, first test, we got two diodes. Yeah, let's try this again. And now we have a capacitor. I've seen that thing before that it says two diodes first, then you try again, it's reading something. Now, the capacitance has decreased to 900 microfarads, so that's not good. And the ESR, it's only 5 ohms, but I got a 33 ohm resistor in series. Now I have another component here. This is a worth 1000 microfarad, 25 volts. Let's see how much it reads without anything, and then we'll try the little trick again. I'm reading 961 microfarad, 0.29 ESR on the, let's call it generic reader. And I'm reading 1032 microfarad, 0.16 ohm ESR on the FNIRSI. So yeah, I mean, the values are a bit different. It's not great, but more or less, you know, I got something that looks correct. This is a brand new capacitor, by the way. I've soldered another 33 ohm resistor to this capacitor, and let's check it out. And I'm reading 1000 microfarad, which is more or less where it was before, and 34 of ESR, which is more or less correct. I got 33 for my resistor plus the internal ESR of the capacitor, so more or less 34. I think we don't have resolution, the point resolution, the decimal resolution at this magnitude of ESR, so that's totally fine. Let's see what the FNIRSI is doing instead. And as before, we have two diodes. So let me try this again and read it again. Come on. Doesn't like it. Ah, okay. What's a GUI issue? So if I'm testing it again, it finally reads the capacitor, and so the capacitance has decreased a lot. We have 869 microfarad, and the ESR is only 5 ohm, which is completely wrong. Now, does that mean that the FNIRSI is not reading ESR correctly? I mean, this is not a conclusive test, because as I said, the firmware is using some electronic trickery to read the ESR, and a resistor soldered in series with a capacitor might not work with that method, with that methodology. So the fact that this is actually working and reading the resistor as ESR and this is not, it doesn't really mean much to me, but many of you mentioned this technique, and again, it works on this, it doesn't work on that. But once again, it doesn't mean that, you know, it's not using the traditional way of measuring ESR, so for whatever reason, it doesn't work with the FNIRSI. Now, the next step is to compare brand new known good capacitors on both testers. So this is a 220 microfarad, 50 volts. It's an FR capacitor from Panasonic. This comes from either DigiKey or Mauser, so I'm 100% sure that this is genuine. So this is a real Panasonic part. And Panasonic says that this capacitor is supposed to read at what frequency? I don't know. And Panasonic says that this component is supposed to read an ESR of 0.03 at 20 Hz, but 100 kHz frequency testing. So let's see what these two component testers say about it. We got 229 microfarad, VLOS 0.7, ESR of 0.25, so this is like 10 times higher. But once again, I don't need a level of accuracy. From my point of view, 0.25 is very good, but this capacitor, according to Panasonic, and this is a brand new capacitor of course, should read 0.03. And the other test is reading something similar, the capacitance is very similar, and the ESR is also very similar, it's actually a bit higher than that one. So what does that mean? Well, it means that these devices are nowhere near to be accurate, and I don't know. I mean, again, from my point of view, 0.31 means very good, but again, according to Panasonic, these should be 0.03. So obviously, you know, it just makes you understand what you're dealing with and what kind of accuracy you're getting from these devices. This is the 1200 microfarad at 35 volts we were dealing before. It's another FR capacitor, and according to Panasonic, this should have, it depends on the case size apparently, I didn't know about that, it should be 0.015 ohm of ESR, so let's test it. And I'm getting a 1300 microfarad at 0.03 ohm, which is kind of weird, because earlier on I tested it and it was 0.23. So let me test this again out of curiosity. No, it's more or less right there. Let me try and discharge this before it's being tested. It's more or less there. I don't know why, maybe I just wrote it incorrectly. I have 0.23, but it's 0.08, which is not bad. It's only twice as much as what it should read. And let's see what it reads on the older component tester here. And it's reading I would say the correct capacitance, but the ESR is so much higher. Again, this should read 0.015, so this is actually closer than this one. Now, as a final test here, I got an FC capacitor. It's a little, I would say, higher ESR than the FR series, and this, because it's very small, is rated 2 ohms. So it's quite a difference between the FR that we were testing before. So let's test this one. I'm really curious to see what it's reading. And the FNIRSI says we got an ESR of 0.04. Again, earlier on I had 0.11. Now it's 0.04. The capacitance is, I guess, is correct. I think this is a 10 microfarad, 25 volts. So we are more or less there. Let's see what the older tester says. We got an ESR of 2.1, which is actually what it should read. The datasheet says 2. So 2.1, it's pretty accurate. So it looks like this tester maybe is not very good at reading lower than 0.2, 0.3 ohm, which again, for my case use, for my purpose, is totally fine. The FNIRSI is a little bit hit and miss, because again, I was doing some tests before shooting this video, so you know, I knew what to say. And this is reading something, it's not completely different, but again, earlier on it was 0.11. And this earlier on was 2.2. So 2.2, 2.1, you know, I can accept that. But from 0.04 to 0.11 earlier on, it doesn't make sense. We got 2.3 now. Earlier on was 2.2. A moment ago was 2.1. I think it was. It's fine. Again, these are not LCR meters. They're like 5 pounds. and that's the kind of accuracy I'm expecting from these tools. That's totally fine. So again, another little question mark on the FNIRSI. As I said in my intro, one of my viewers, Scott, from Defpom's electronic repair channel from New Zealand. Hello Scott, hello New Zealand. They have this TC3 device. They actually reviewed it in one of their videos some time ago. And they watched my video and they basically got in touch. They commented actually saying, look, I got the DE5000. I can do a comparison on one of my next lives. Scott was kind enough to let me grabbing a section of this video where he's doing the comparison and placing it here on my video. So let's move to New Zealand and let's see what Scott has to say when comparing the TC3 with a proper LCR meter.
So let's look at this one first, see what we get, and do a test. So it says 36 microfarad, 0.2% VLOS, ESR 0.48. Remember all that? It shows it on screen anyway, so it's not too bad. But let's check it on this one. We'll see what the DR says. Bit of a difference in capacitance here. So let's do different frequency. Now I tend to measure electrolytics at 100 Hertz or 120 Hertz if it was available. So now we're getting 32, which is much closer to 36. Okay, so let's look at the options here. Dissipation, 0.2, we've got 0.2 there. Yeah, so ESR 11 ohms. This one said 0.48. Yeah, that's interesting, which is what the same thing which Tony was having issues with. This saying much lower values than this was saying. Okay, let's get this big one, see what this one does. Okay, let's get another one. Because I want to get conclusive testing saying yes or no, this is good and no, it's bad, or whatever it may be. Very slow to test, one thing I did notice. So it's 217 microfarad, voltage loss of 0.4, ESR 0.4. What I do like is the way it holds it on screen. I do like the way it does that, because it means you can refer to it. So this is a 220 microfarad 10 volt. And so some of these caps are good, some might be. I don't know which one this is. It says 202, 3.9 ohms, very different. Okay, I've got one more capacitor here. Let's try one more. But so far it seems like this is just really not good. Capacitance aspect of this seems to be pretty rubbish. Why is it not testing? No. There we go, now it's going. That took a while to get going. It's like it got stuck for a second. So that says 7266 nanofarad. Voltage loss 0.2, ESR 0.2. It's almost like the V loss and the ESR are misreferenced, because it always comes up the same numbers. And I find that interesting, because maybe someone's used the wrong variable reference in the firmware, so it's actually not looking at the ESR. And here we're getting 7.388. So similar capacitance, 18 ohms. Yeah, nah. But this seems to be completely useless for testing capacitors. I wish I'd noticed that when I did the review.
And the outcome is not great, is it? So thank you very much, Scott, for helping me out, for doing this comparison for me. Please do subscribe, leave a comment, like Scott's channel. It's been really kind, particularly for allowing me to include a section of the video in my own video. One thing I've noticed is that Scott used the 120 Hertz frequency to test those capacitors and do the comparison. And again, I read online, I found a few tables, and I understand the 100 Hertz or 120 Hertz reading can be as high as like twice as much or even 10 times as much as the same ESR being read at 100 kilohertz. So I don't know, that's a big question mark, but I think it's pretty clear at this moment that the TC3 is not really good at component tester when it comes to capacitor. For everything else, I don't really know, but I honestly need this for capacitor, so that's the whole point. Now, before finishing this video, I'm actually curious to see what's inside this thing, because I got it for free, and honestly, I don't think I'm gonna use it, because it's not being accurate when it comes to capacitors, and that's the main reason I need it. I'd like to take a look, because I can show you what's inside the older component tester, but this one, I guess it needs something removed or you know, pried off, because I don't see screws here, so maybe we can take a look together. Now, this older component tester, as I said, has an Atmel Mega 328 IC, and I think that's the original design that I found online, that document from the German engineer that I mentioned before. Let's try and open this one somehow. I'm not entirely sure how to do that, because I don't see any screws anywhere. It looks like this is not designed to be open, unfortunately. I don't feel anything under the label here. Well, I guess there's not much that I can show you. There's a little bit of some logic here, some inputs IC, multiplexer channels. I don't even know how this works, but the main IC, which is doing all the calculation and the electronic wizardry, has been erased. So we don't know what that IC is, and I can assume it's based on the old design, but I don't really know. It's a much bigger IC than we have here behind the old one, which you can't probably see. But yeah, I can't really say what that is, and I have no idea how these things normally work, so I can't even speculate what kind of IC that is. But again, unfortunately, it's been erased, so there's not much I can tell you about that. So I guess this is it for this video. The main thing I wanted to show you is that when it comes to ESR, these component testers are not using the same methodology that is being used by proper LCR meters. And I'm incredibly blown away by how the original designer managed to get this level of accuracy with just a little bit of electronic wizardry. So absolutely fantastic. If you know a little bit of electronics, just go and take a look at that documentation. It's absolutely amazing how they managed to achieve that with so very little. So what can I say? I guess this is the end of the video. I hope you enjoyed it. If you did, I would particularly appreciate a subscription, because I haven't got many subscribers to this channel yet, and that would really help me with YouTube and the algorithm. If you didn't, well, you know what to do. Also remember, I'm on Patreon, and let me thank all my patrons. Their names are scrolling here at the side of the screen. There's a free tier on my Patreon account, so you have no excuses for not joining me. If you don't want to join my Patreon, which I completely understand, you can buy me a coffee. The link is down below in the description. If you don't want to buy me a coffee, you don't want to support me on Patreon, you're still welcome, and I still thank you for watching this video and for your time. That's it for today. I hope to see you again soon here on this channel or on my main channel, and for now, thank you for watching and have a great day. Bye bye.